All right, good morning, everyone. Welcome back to Forward Cloud Sec Day 2. I hope you all had a good time at the happy hour last night and had some good conversations at our Birds of a Feather session. As a reminder, we'll be setting some time at the end of the talk for questions, so please think of them as you go along. For those of us following along on our live stream, we will have question threads in Slack, so feel free to also leave your questions there. Our first talk of the morning is The Path to Zero Touch Production by Rami McCarthy. Before we begin, we'd like to thank all of our sponsors who've made this possible, in particular our gold sponsor, Kyvera. Kyvera provides a purpose-built proxy for cloud APIs that enables preventative guardrails and data perimeters. Unlike other solutions, Kyvera gives you granular parameter-level controls with 100% support across every AWS, Google Cloud, and Azure service. Prevent insecure resource configurations, stop data exfiltration, and simplify cloud compliance. Kyvera, your cloud, your rules. With that, I'll turn over to Rami. Thank you very much.
Hello. Hello? Yeah? Oh, okay. I can't hear myself. So that's great. Thank you all for being here this early in the morning. Thanks to all the Forward Cloud Sec organizers for putting this on and letting me come and talk to you about Zero Touch Production. I'm Rami. A little bit of connecting the dots for folks. Sometimes I use a Scooby-Doo profile picture online. So if you've seen me in various security Slacks, that's how that all ties together. I'm currently on a bit of sabbatical, so I'm spending a lot of time writing, including for TLDRSec and Venture in Security. I'm also working with a couple startups, including P0 Security, who do a unified cloud access governance platform, and Conducto, who are an ASPM. I also maintain a bunch of knowledge hubs on GitHub, including one about all the AWS customer security incidents. If you want to talk about any of these things or anything in the presentation, come up, say hi throughout the conference. I'm always happy to meet new people, connect with old friends. So let's talk about touching production and why we care, right? Always establish the problem first. I think the basic thing I want to focus on is that mistakes happen. We'll talk a little bit about other risks, but fundamentally, when you are working in your production environment, you always have these fears about applying the wrong Terraform workspace or deleting the wrong database, or you go to run that RM command and then you realize your shell has the big red banner that says this is the production shell, please don't hurt me. So mistakes happen frequently. There's a Google paper we'll talk about in a bit that found that 13% of all of Google's instances were due to human interaction in production. So this is at Google scale, a huge ability to save some money on the cost of those instances, and a huge ability to help make working safer and more reliable for our coworkers and colleagues. The security side of this is that access is attack surface. Fundamentally, any access you have is access an attacker gets when they steal your session or credentials off your machine. And something we try not to fixate on is that access can be abused. I think it's important we maintain a posture of trust with our coworkers. We don't want to become an antagonistic security team that's looking around every corner, but the more access you grant ambiently, the more folks are working day to day with dangerous tools, the easier we make it to make a bad decision or even a malicious one. To lead into the zero touch production thing, I'm going to lay out a bit of a cloud access maturity journey. This is basically a progression I see companies go through, and you'll probably identify with one of these phases, and will culminate in zero-touch production. I also am going to write up a blog version of this in longer form as well, so that'll be available following the conference at some point. So I think whenever I talk to an early startup or you meet a company going through a cloud transformation, there's this very basic level of access to the cloud where everyone has admin, everyone's shelling into production. It's probably SSH, it's probably SSH over the internet. Maybe you're using IP allow listing. And this is fine until you hit 10 to 20 engineers, right? If you're regulated, I'd love to do better. I'm sure everyone in this room would feel uncomfortable with this situation, but it's a normal part of growth. And then you move into this first pass at cloud access where you're doing standing RBAC, you have those first few roles. You also are making shell and admin broadly available and they're used a lot. but you're probably not giving them out globally. This is where you have like maybe some finance folks who don't need admin in your cloud environment. This is roughly the 50 engineer point. If you're not breaking out roles, you should start to think about that really hard. And then we hit like established cloud access maturity. You have granular RBAC, maybe it's team-based, maybe it's product versus platform engineers as well. Shell and admin are probably specific tools that you use when you need them, but aren't daily driving. And maybe you have a few narrow capabilities. So I often see like database operational tooling broken out pretty early, where you want like some category of DB admin taking actions that not everyone would, like deleting databases. You also want to start to have those technical controls around lifecycle. Onboarding and offboarding gets important because it's fairly frequent at this point, as well as deploying some level of just-in-time access to step up to those more privileged roles that now exist to use those tools you're starting to build. This is actually a really common plateau. I think technically this sort of posture meets like every compliance requirement and probably most security frameworks. We can do better, but it's worth pointing out that like anything beyond this is a matter of business value, whether it makes sense for your risk posture, whether you need to do it. Everything up to this point, though, I think is pretty mandatory if you are building a cloud security program. So the next stage, like when you're doing relatively advanced cloud access, everything just gets more granular, more governed. A big play here is automation and observability. One of the easiest ways to get people out of touching your production AWS environment is to pull out all of the debugging data they need into observability tooling that is safe and ergonomic. You also start to have internal tools, right? Maybe you have a CLI wrapper for cloud operations, maybe you have a web portal that gives you like one-click rollbacks, whatever it is, anything that is common. If it's happening once a week or maybe even once a month, it's probably abstracted out into a safe tool. And just-in-time access goes from like I step up to admin to I need to touch this one S3 bucket or this one customer's data in RDS. And this is where we hit zero-touch production. So the zero-touch production thing is a Google talk that was given. The talk is excellent. If folks haven't seen it, I recommend seeking it out. The point I want to make about zero-touch production is that it is a North Star and not something that I'm saying everyone should do. We are all not working at Google. Maybe someone is. If you're working at Google, you probably are doing this great. For the rest of us, it's a lot of overhead and complexity that we can learn from, but we probably don't need to emulate in whole. And what is the zero-touch production thing, right? Sort of self-evident on its face, no one's touching production. But in practice, it's all about building automation or sort of safe pre-validated paths to interact with production, and when you need to, breaking glass in a way that's audited and mediated. So this is all about like moving those production processes to safe, narrow APIs that you can work with. And I would add that I always think of zero-touch production with one additional caveat, which is that I like every touch to be pre-justified, which is to say I would love my users to register their intent before they go cowboy changing things. Because when you're going through the auditing process, like it's great if I have a log that you went and modified production. Trying to understand whether that was reasonable is deeply contextual. And so by making users register their intent, you give them a speed bump of like letting them explain the business process that's going on, which also will inform later on as you try and make those processes safer and easier. A couple like key implementation details to breeze through here. The first is like the concept of safe automation. So when you're building automation, you want to build in rate limiting. This is like blue-green releases or maybe tight limitations on rollouts to production of new configuration changes with support for rollbacks. You want safety checks. So for example, like maybe there is some upper limit on how much production traffic we can disrupt at any given time. And so if I click a button that says like roll all the production boxes at once, don't let me. Obviously without approvals and very explicit whatever. And then also you have to think tightly about authority delegation, because any tool that is working on production, we've built all these tools, great, no humans are touching it. Now we have a bunch of highly privileged tools that are mediating access and have their own complexity. Google also goes with the safe proxies route, and this is a place I don't think fits every company. Really concretely, Google runs a lot on RPCs. And so they have like an RPC proxy that does the audit log and the authorization layer and some rate limiting as well as letting you do delayed approvals. So you can sort of register that you're going to take an action, and then the system can wait for an approval at the proxy layer. If you're not using RPC internally, I think it gets much harder to build this sort of universal proxy because of just the diverse protocols and platforms that you're working with. So that's a maturity curve. What do we do about it, right? Like, okay, great, I would love for my engineers to be operating like Google does, or I would love my engineers to just be operating a little more safely. What's the actual organizational change process you can go through? It's not as easy as just telling people they can't touch production, and I don't actually think you should start there. If anyone heard Forrest last night performing, he actually poked fun at the sort of architect who just flies in and says, you can't do this anymore, you can't touch production, and moves on. I think you're seeing some of his Google lineage come through there. But it's not as easy as don't. Security is about enabling the business. It's about helping our coworkers be successful. It's about providing value. And I think most people here have heard the security should not be a culture of no thing a lot. That being said, I think with access changes, there is a safety element that is fundamentally going to add friction. It is the easiest possible thing to just have admin and have everyone use it. So it's all about thinking, what are the ergonomic benefits, what are the developer experience benefits, the safety benefits, the reliability benefits we can bundle so that as security teams, we're not making arguments just for security's sake, but as a complete company transformation maturity move. And again, engineers are touching production for good reason. They are not, if any of you have worked with sysadmins or DB admins, there are some who just go willy-nilly, but many of the engineers I talk to throughout these processes are terrified. They absolutely hate that they have to, in their second month on the job, shell in and start running commands on live traffic. It is no fun for anyone. And so there is a business need there. But if we give them better alternatives or paved roads, I have seen that people will grab onto those. So how do you move up the maturity curve, right? We'll breeze through a little animation here. This is the process as I see it. I think you want to start with some baseline metrics because it's going to be a long journey and you need to encourage and justify that on an ongoing basis. And so if you just say our goal is zero touch production, in a year and a half when you're not there, everyone's going to wonder whether it's worth it and what you're doing. So you need to think carefully about how you can actually advocate for this on an ongoing basis. I think you start by making the shell access you're using safer before pivoting into breaking off parts of that access into alternatives. You then can reduce the standing access so that people are funneled into those alternatives. Once people are funneled into the alternatives, they start to get upset. So you improve the DevX of the alternatives. You dangle a carrot there. And then as time goes on, you do eventually add friction to risky access. And I see companies be really afraid of this because it is potentially an antagonistic action to make it harder to reach production. You'll hear a lot about what if there's an incident. However, I think that you have to build the confidence yourself in the tools you're building and the options you're giving people so that you feel comfortable increasing the friction. And if you don't get the buy-in to increase friction, you're going to end up stalling out. So there's a bit of thinking about the organizational support you have there. And this then cycles through, right? You're gradually decreasing the standing access, decreasing the level of capability in some sort of default shell, and breaking out narrow, granular, well-controlled tools to provide a much stronger security model. I'm going to dive deeper into a few elements of this and talk to you about the details. So to talk about the details, we have to talk about why this isn't easy. And I think that there are both technical and social challenges or organizational challenges that you'll face. On the technical side, transitive access actually makes this really hard, and the more you peel back the layers, the harder it feels. Anytime someone can touch production, even if you have it very limited, requires really strong segmentation internally and visibility of data flows, because once that data starts to move out of production, you're now caring about your whole enterprise security posture. Similarly, if you can get a shell in production, you have transitive access to all the data that your production service is using. You also have access to things like secrets and environment variables that can walk off. Any of those long-lived portable capabilities make it really hard to track access. Audit logging is also, audit logging, just implementing the basics, can be challenging, but what's really hard is with shell access, you have a lot of interactive sessions. And if anyone's looked at the logs for interactive sessions, you end up making a trade-off between whether they're easily parsable by machines or easily human readable, or you do the extra effort to do both. And then even if they're parsable or readable, a single line of bash history has very little context. There's a huge room for obfuscation and interruption. And it ends up just being really challenging to write the sort of, just-in-time detections we'd love to say, is someone who's actively on the shell running a command? And this is where you have to move into layered security controls. There's also a lot of new moving parts. So not only are you now the SREs responsible for how people are accessing production as a security team often, you've also just created a lot of complexity around really sensitive systems. And so there's increasing burden of securing those systems, managing them, providing break glass alternatives that grows. On the organizational side, what you'll notice is that it's really normal for users and systems to get used to the ambient level of privilege. If you've built a system where somehow every service is running as admin, going in and trying to understand the logic behind the permissions it's using and whether they're necessary or not gets really complicated. And same with users. Going from, you'll discover all sorts of weird processes and user behavior that has grown when they're used to being able to just hop into production. You'll also find the organization may have stunted the development of things like observability or debug tooling because they're used to people just being able to hop into production. Building prescriptive paths is necessary to get here. I think that there's no way to build super flexible tooling and do this safely. However, in organizations where you're not used to being prescriptive, you're going to have a lot of pushback where engineers are used to being able to work their way, and suddenly you're funneling them onto these narrow paved roads. And so again, you have to do a lot of research and discovery to figure out what engineers actually need. Moving the cheese is the final organizational challenge. I've seen this a lot when you're implementing these new tools. It can be really disorienting for engineers, especially tenured engineers and especially VIPs, to understand why their expectations for how they would respond to an incident might change. And so there's a huge education component, documentation, enablement element to making these changes, because the last thing you want is someone to get woken up at 2 a.m. and try and run a command that doesn't work anymore, and then wake you up at 2 a.m. so you can explain to them why this is safer and we should all be happy about it. So beyond just the challenges, right? We're going to start with making shell access safer. We're going to talk about alternatives. We're going to talk about DevX. So making shell access safer, this is going to be a speed round where I tell you every way AWS offers a primitive to get a shell in production. And then I'll tell you which ones you actually need to care about. And when I say getting a shell, I'm going to mangle two concepts, and I don't care. There's an element of this that is networking and reachability of the systems, and there's an element that is authenticating to the systems. And you can mix and match. If I mention SSH and VPNs, and you want to switch that up with internet exposability or IP allow listing, more power to you. But you should have both. The model where you're doing an M&M with a hard perimeter and then no authentication once you get past the VPN is going to cause you a lot of trouble down the line. Also, some of the AWS primitives do just sort of solve these for you. So we start with SSH because that's where organizations start. If you've ever been manning a detection feed and you've seen Launch Wizard 1 pop up, it's a great sign that someone has ClickOps the AWS console and opened port 22 to the internet. It's a great default. I love that they do that. It hasn't caused problems for me ever. But yeah, SSH is familiar to folks, and you are using authorization, so I've seen worse things in practice. But fundamentally, where SSH becomes challenging for me at scale is the key management and the decentralization, right? If you've ever had to try and manage public keys across a fleet and then manage private keys and key rotation and whatever else you want to care about, it gets a little challenging. Adding in a public bastion is nice because you're decreasing your internet-facing attack surface. You're only having like one or a few servers that you actually have to patch and keep up to date and care and feed for, and maybe you're smart and you make them like containerized cattle instead of pets, and then this all gets a little easier. But you're still managing keys, and you are still dangling an SSH server on the internet, and like racing O days in your or 1 days in your SSH server is no fun for anyone. Plus, you have to worry about like whether you're going to do key forwarding or whether you give people a key to get on the bastion and then shared keys. So there's a lot that sort of can be annoying about this. It works early. I don't think it will scale for you. EC2 Instance Connect. AWS service. Basically, it's a way to make that key management problem a little easier without solving anything else. If you somehow are doing a ton of SSH, this is worth exploring. Basically, it lets you make an AWS API call to set up a temporary public key someone can use to SSH in. You still have to solve for network reachability, so you're still probably using a public IP or something, but at the very least, you're not physically, putting keys long-term on hosts. However, this also gets confusing for engineers. I've had a lot of engineers like take 61 seconds to SSH in, and then it doesn't work, and then it's my problem. So keep in mind that like this breaks people's mental model of how they should SSH, which can add some overhead. So then you move into like traditional VPNs. AWS has 3 separate VPN services at least. Client VPN is the one that you would think of as like a traditional VPN concentrator model. It's nice because you don't have public-facing surface, right? VPNs are also the like AWS services mean you're not managing a VPN concentrator. And if AWS has had vulnerabilities in their VPN endpoint, they at least haven't told us about them, so you don't have to worry about that. It's also nice because like a VPN is the networking side, and then you can just solve the service side separately. But now you're adminning a VPN and dealing with that, and not my personal preference. You're taking a DevX hit on like, am I on the VPN questions, and figuring out which VPN you're supposed to hop on to which VPC, whatever it is. VPNs are also like on the more expensive side of the things we'll talk about. So there's also like cool VPNs, which is WireGuard. I'm a fan of Tailscale. There are a lot of sort of competitors, or you can deploy this yourself. The thing about WireGuard is like you have the pros and cons of VPNs, but with a little better developer experience, with a mesh network, so you're going point to point instead of having to transit through a central place. The downside about WireGuard is that auditors are not super familiar with it, and so if you are used to your auditor getting confused by cloud tech, layering in a description of WireGuard can be challenging. However, you can just tell them, hey, this is a VPN, and they probably won't ask further questions. Okay, so SSM, right? SSM is SSH for AWS, right? That's a terrible description, but fundamentally SSM is the solution for allowing people to access a shell. You get IAM management, you get audit logging, it is free. The downside is that you have to deal with AWS CLIs, which handing a developer who's used to like typing SSH, one of those commands can be really intimidating. And there is an agent involved that you have to like distribute and manage. This has gotten easier over time, but if you have a very weird fleet, that can be challenging. EC2 Instance Connect endpoint is called the same thing as EC2 Instance Connect because it's also a little bit about managing SSH access, but different service. The nice thing about this is it basically gives you an endpoint in each VPC that you can then use without putting public access out, still with SSH and those ephemeral keys. You get the IAM, it's free, it's a reasonable solution if you're doing a lot of SSH, it gets you off the internet. It was really cool when they announced it because Aiden published this tool that showed that you could do RDS access over it and any service you wanted, and then like 20 hours later, AWS locked it down to just SSH and RDP. So the protocol supports it, but AWS does not allow you. Also a really clunky CLI that's enabling you to do TCP over SSH over WebSockets, which adds a lot of layers of trouble and overhead. And the logging is suboptimal here. Okay, getting into the tail end here. ECS exec uses SSM to Docker exec, basic premise. The logging ends up being, I think, better than SSM just because you're specifically working with that exec. But comparatively, right, you can just use it for ECS basically. It's not a super flexible tool, and you can only have one session per PID. Anyway, you will hit session limits, but if you're hitting session limits, also probably too many people are using the thing, so maybe that's actually a pro. Zero Trust Network Access. AWS Verified Access is AWS's version. This is Cloudflare Access, Okta ASA. You can also build your own identity-aware proxy. There was a blog post Figma wrote that you can go Google up. Basically, this gives you SSO integration for your internal apps, especially internal web apps. Very good if you need to serve internal apps on a private network to non-technical users, but it's going to be more expensive than almost anything else we've talked about. And there's a comparatively high complexity of like deployment and administration, just because there is a fair amount of infrastructure and networking to solve for here. Last two weird ones. Like I was researching every way to do things and I found these. VDI, not that weird. It's Citrix, but AWS for Amazon Workspaces. Really flexible, good for non-technical users. You basically give them a computer in the cloud. The problem is that adminning this sort of ecosystem is hard. If you use this to like give people Windows boxes, you can't forget that you're now doing Windows security in this separate part of your infrastructure. Ideally, you can take this and turn it into like a safe workbench where data can be placed but not exfiltrated. In practice, that's really hard to do. There's also Cloud9 like lets you shell into things, which I didn't know and have never used Cloud9. Sounds great like for development if you have remote development environments and you want to like access EKS. I wouldn't use it in production. I don't want to have to figure out like how to log people's usage through Cloud9 of this sort of thing. So the TLDR, right? Like what's the actual guidance here? Use SSM. I think getting away from SSH is pretty easy in AWS, and you can do SSH over SSM. But fundamentally, SSM is a good tool, and it is free, and it gets you most of what you need. ECS exec is actually good enough to layer in as a dedicated subset if you're using ECS. I would ignore the rest of it unless you are doing like some sort of digital transformation of a lot of SSH, right? Like these tools have their place, but start with SSM and ECS. I then add probably WireGuard first, probably a like mesh VPN to start to expose things that maybe have UIs. Gives me good intrinsic security, good DevX. I find like identity-aware proxies a little more complicated and hard to roll out. But if you're dealing with a bunch of internal web apps, if you hit that point, that's probably sort of completes the ecosystem of tools you need there from the primitive side of things. So those are the ways you can do shell. How do you make shell access safer, right? Folks are touching production for good reasons. What we want to do is we want to look at the reasons people touch production and then solve for those cases without giving them a shell. This, most of the time, does not involve an interactive session. Oftentimes, people are spinning up a shell to run a single command that they run every morning, right? Should have been a cron job. And so, like, where I've broken out things is that I think all access to production can actually be done through one of 6 capabilities. Like, I have a nice taxonomy I feel like I've broken out, and you can all come up to me after the talk and punch holes in it with special cases. So I think the first thing is script running. And we'll dive a little bit into the implementation of a few of these, including this one. This is where you have a predefined command or set of commands. You have allow listed or well understood arguments that are safe. And so you can give people a well-structured way to do a repetitive task, right? You need some way to expose this, probably like something that's version controlled and checked into GitHub so that security can review it and then it's safe to use on an ongoing basis. Similarly, there's asynchronous jobs. Often these two systems are mingled, but you want some way for folks to sort of pre-register and schedule recurring things. This can also come into play with like database migrations. Oftentimes this is somewhat application layer or like whatever your app platform is. There's also an AWS service I've never used and so can't recommend, but that exists and seems to do this, which is always a dangerous trap. You also want some way to quickly build internal tools, because as you're discovering new use cases, you want a way to funnel the small ones off. And this might just be a UI in front of script running and async jobs. This might be a CLI tool to wrap it and expose it. SSM port forwarding can do a little bit of exposing some of these internal tools on local ports. There's also Clutch, which is a Lyft open source project. It's not super fully featured, but it gives you an example of how companies go about this. Retool, right? You can go this path of paying a vendor for an internal tools platform. It has its trade-offs. And I see a lot of folks shoving it into the admin console of their, whatever their web framework is. I've seen it with Django a lot. It doesn't scale forever, but it does give you an easy place to drop internal tools. You also eventually need a workbench, and I find this the hardest thing to build and the one I always put off till last. The idea of building a place where someone can work on customer or sensitive or regulated data without it touching their laptop and without them being to exfiltrate that data is like a nice dream, but in practice it's very hard to give people ways to manipulate data without ways to exfiltrate it. This is the sort of thing that you have to think of very specific examples for your business if it's necessary or not, or if you can just say, please don't touch the customer data. I've seen very complex file formats or very complex data modeling for a specific customer. When that starts to cause bugs and you have really hard time reproducing it in test, there can be some interest where customers give approval to work on their data, and now you have to figure out how to do it without the data growing legs and walking off. Read-only analytics is pretty early in the process generally. You have this whole pool of data in prod, and some of it is actually safe, right? You have usage metrics or what have you in your database. And so by building a easy platform for users to touch the safe data, you've offloaded a huge amount of the time that they're going in. This can be as simple as adding a read-only IAM authentication to RDS if you're small and people like using pSQL to access things. Often this just is about streaming replication to a data lake of the safe data, and then you solve this all in Snowflake, exercise left up to the reader. Finally, this all gets wrapped with break glass, just-in-time access. Just-in-time access to these tools, just-in-time access to roles and permissions. It's what kind of ties things together. And it's important to think about just-in-time break glass as not just read-write, but also read-only. A lot of the time when folks are breaking glass, it's to answer a question and not to make a change, and so you can offload a lot of that. Okay, so let's talk a little bit more about some of these. I wanted to quickly share, to drill this in, what sort of internal tools do people build? What are the common actions they're taking if you haven't encountered this? Resizing, scaling, coordinating nodes. These are all examples from Clutch. This is the sort of thing you'll end up bundling into a script or internal tool that otherwise would require someone to be manually fiddling with production. One way to do this is SSM run command, and I just wanted to give a quick preview. SSM run command is really fun, and I think folks don't use it enough. Maybe that's a hot take, but basically it lets you bundle up a script and expose it as something that people can use IAM to call against specific instances or hosts. And so for any number of scripts people normally run on services in your environment, you can just instead make that script into a little document and make AWS solve for the authorization infrastructure. It's really nice to be able to use IAM to manage who can run a script on which instances versus having to build your own intermediary authorization layer. And digging into just-in-time access, right? I think that this is really key to a smooth migration because you can ratchet friction by increasing the amount of approval required, by increasing the latitude of the person who has to approve your access, who you have to wake up to do something scary. It's also a really straightforward way to end up with that break glass because you're just making a just-in-time request. It happens to be one that's scary. And it simplifies user access reviews because compliance normally makes your review standing access. And if almost everything is ephemeral, you have a much smaller pool just in time where you have to actually go through and do that process. And so you can use this to do access for on-calls or on-demand access. You can use this to create multi-party approval. It gives you a great choke point for logging and for generating metrics. When I talk in a bit about metrics for this sort of access program, a lot of them come from a just-in-time tool, because generally these tools are able to generate metrics and are centralized, unlike a lot of the rest of what you're doing. There's a couple cool open source options here. The one from Discord is new-ish and seems really exciting, and I would love if we would all just like centralize on that and stop paying vendors to build just-in-time tooling for that set of use cases. I think it would be cool. There are also, I don't know, like 15 listed there and another 5 who are gonna DM me after this and say we should have been on the slide, but there are a lot of security products that do just-in-time these days. You may even have one already, you may even have one that does it and you're not paying for that feature. Who knows? So I want to finally talk about DevX because this was one of the things that I found least intuitive and least documented, is like, what are the things we can do to improve the ergonomics of accessing AWS, especially as we add all of these tools and capabilities. The first one is actually about a browser extension. And I have mixed feelings on this because it kind of scares me to put a browser extension on every user's laptop that can interact with AWS. Like, I fully acknowledge that is a scary thing to propose. Work through it yourself. But AWS is notoriously bad at the developer experience. If you have ever logged in through SSO, you have to like click allow and confirm some code you never see anymore. And this is after you've logged into Identity Center, but before you've logged into your account. And you can actually just create a browser extension that auto-clicks these. Ideally, AWS would move to a more secure like localhost model, but until then, that's useful. It's useful to remind people to refresh their sessions if you're doing just in time. Identity Center, you need a new Identity Center session for new roles to show up. And so someone will like go to the just in time tool, get a new role, go to AWS, not see it, go to the security team and ask a question, right? Just throw a banner up on that page. It saves you some time. And there are a lot of tools out there that help use this to manage browser tab containers so you can have multiple AWS accounts open at once. The other thing I'd pitch is a unified wrapper. In my experience, it's a CLI, but I guess you could do this in a UI as well. This is huge, and I would start early. So you probably are using something like AWS Vault or Granted or an equivalent, so you're not dealing with native SSO flows pretty early. What you want to do is you want to wrap that in a custom tool for your company. And why you want to do this is because it lets you add all sorts of customization around like advising how to use specific roles or checking error messages on some commands and telling people whether it's a permission issue or access to the role or an SCP. And all of this siphons off engineer frustration and time security spends educating. It also gives you a single entry point for access. So like you could call the command access and say access EC2, access ECS, right, whatever. And then you can give people an interactive prompt to pick the instance, and you can do instance discovery for them. And then when you want to move from SSH to SSM to ECS exec, you can do that all in the background without having to change people's workflows. So like that implementation change, that interface change, the longer you go on in this process and the more you're splitting off is really helpful because you'll get a lot of change fatigue otherwise. Finally, you can collect metrics. Getting like metrics on number of access errors people are seeing can be really helpful from the endpoint. Getting usage metrics on each of these tools centrally can be really helpful as well. So having some instrumentation always helps. I keep like saying metrics and waving my hands, and that's what we do in security, so I don't feel bad about it. But like, I will give you some examples of mediocre metrics, because if I had good examples, I'd use them. But anyway. So like access program metrics, right? You can do number of employees, or I link a blog post here that talks about access hours that Temporal used. And this is like an easy line goes down for ambient risk exposure on access. I like comparing usage metrics on like a legacy high capability shell to tightly constrained tools, because generally those are inverse, right? Like you see fewer people using scary tool and more people using safe tool, and you feel good, your manager feels good, you move on with promo. Also, mean time to approval and auto approval rates are good because generally as you build these tools, you want to make sure that you're increasing the rate at which people can get the access they need while still being safer. And this one's hard for many companies, but if you do have good incident data with metadata, attributing incidents to human action, doing that can be one way to motivate a program like this, and then once you have the program, it's a really powerful metric that you can tie to financial outcomes. Guardrails as well, right? I think it's important to have these metrics that we're moving and also to be really cognizant that there are ways we can hurt our program and our company and try and measure against that. So like, again, instant data can be hard, but mean time to repair can go up if people are not understanding the tools they should be using. Or you will hear a lot of complaints about it being harder to resolve incidents, and this can be a guardrail metric to sort of balance out maybe some of that subjective feedback. Break glass frequency also is a sign. You want people to be able to break glass, but if they're leaving broken glass all over, something's wrong with the system. Just-in-time access requests should almost always be approved. It should be very rare that someone thinks they're able to do something and they're not. It's like principle of least surprise. So looking at that is really important. And I like a nice fuzzy CSAT, customer satisfaction, right? Like you pull all the developers and they love you, it feels great. They pull all the developers, you hate you. You ignore that, that's not a useful metric. A few outstanding challenges, right, as I wrap up here. These are things someone solved, but I didn't, and I would love to hear if you have. How do we offer a single identity with a superset of effective access, especially in AWS? I am tired of telling people, like, use role A for option A, use role B for option B. I'm sure there are better ways. Tell me about them. How do we handle access denied in the AWS console? Your least informed users will be in the console and will be confused when they hit access errors, and AWS will not help. How do we bring just-in-time inline to CLI workflows and developer workflows? How do we make discovery easier of these tools, right? The unified CLI helps, but how is it we make it so that's intuitive for engineers what tool they need in a specific situation? How do we make the safe workbench thing easier? Does someone have a like solution architecture I can just deploy? Save me the hassle. And we're wrapping up, and I'm 20 seconds over. Read at your leisure. There is a link at the bottom. The slides will be live shortly after this, and then I'll also send them to the organizers. And thank you all.
Thank you, Rami, for a very interesting talk. Anybody have questions from the crowd? All right.
You talk about the metrics we should look at. You also talked about and did not give a ton of detail on what you should log and how you try and synthesize and figure out what developer experiences to think about there. What do you recommend for setting up log analysis, harnesses, workflows, whatever?
Yeah, I think there's a lot for us to learn here. I think security is bad at it. Ideally, you have teams internally that have worked with these sorts of tools and processes more often, and it's a great relationship building. Like, there's that principle that no one is more likely to do you a favor than someone who's previously done you a favor. So going to these teams and being like, hey, I'm bad at logging is great. Logging and metrics are separate, I will say. It's easy. You'll find a lot of engineers doing like logs and lines of activity and then trying to parse that to generate metrics. You can just create both. On the implementation side, for the CLI things, I actually just hook up internal tools to Datadog. There's a little bit of risk of like distributing keys internally, but if it's writing metrics, am I really that worried? From a metrics perspective, I think you want like very point in time who used what, when, that you can turn into aggregate metrics. From a logging perspective, ideally I want to know everything you did while you were on production in a way I can review. In practice, I probably just want narrow tools, so by nature of what tool you're using, I know what you did. And so there's a trade-off there where if you want to be very governed and you're giving sort of these abstract unconstrained tools, your only option is to download the logs from SSM, convert them into human readable, and like stare at them, and that is no fun.
Question of my own I'd like to ask, especially when you talk about some of the things like Google is very RPC based. How do you think about working with the development teams to sort of change the architecture to be more zero touch friendly?
Yeah, it's a great question. I think in practice, I would love to say that actually you should make platform teams own a lot of these solutions. So like an identity-aware proxy is an example where I've often seen security teams build them because we care earlier and it's relatively like a thing we can sling together and get a win on. I think when it's part of the platform, whether that's owned by security or owned by some other team, there's a lot to be said about interfaces for adoption. Specifically like identity-aware proxy, it should be a very easy Terraform config to throw that in front of whatever you're building. I think also it is about having a operational practice that implies some of these granular tools. So something that was really high leverage for me was literally going through and editing every team's runbook away from a broad shell to a granular tool that creates this sort of self-fulfilling momentum where if you are building something new, you sort of understand what it's supposed to look like. I also think that like all of security should be partnership based and you should be working closely with engineers anyway. And if you're only popping in to ask them to do zero touch prod, it's gonna suck for you. And so like the best thing to do is 2 years ago, start building those relationships. And so you already have like distributed influence in the organization. Sorry.
Great. Any other questions from our audience? All right.
Hey, hi, great talk. I was curious, if zero-touch prod is the goal, do you see someone leverage machine learning to essentially predict and prevent malicious shell access, or is it still quote-unquote not safe?
Yeah, I think it's an interesting question. So I think that it's a North Star, but not a goal, which is to say you tack towards it, but you don't actually expect to get there. I really don't think building the like full outlined system is a thing I would blanket recommend to any profile of company. Like there's no type of company where I'd say this is how you must do things. In terms of can we just, provide access but build sufficient guardrails, whether that's with machine learning or otherwise, to compare malice to intentional sort of productive activity? I would say no, and that's just because over time I have become increasingly convinced that a motivated, senior, long-tenured engineer is indistinguishable from an adversary in the things they will do in your production environment. I've seen people download things off DigitalOcean and run them. I've seen people nuke servers because they wanted to see what happened when it comes back. I've seen people curl pipe to bash in prod, and all of these are people just doing their job who are very lovely and like trying to do the right thing. And so I think the idea that yes, you could probably build sophisticated systems to flag that activity, but it's much easier in security to just make safe paved roads and funnel people onto them and not worry about it. And my problem personally is I'm very anxious. And if I were relying on some sort of system to detect the malice, I'd have to worry about it. Whereas if I just give them a defanged tool, it is no longer my problem and I can remove that cycle from my brain. So that's the trade-off there.
All right, thank you very much, Rami, for a talk, and we'll be back here in a couple minutes. Thank you.